Our pale blue dot, Earth, faces immense challenges. Climate change, resource depletion, and overpopulation threaten our very existence. The rapid industrialization and urbanization have led to an unprecedented strain on our natural resources. Forests are being cut down at an alarming rate, leading to loss of biodiversity and contributing to climate change. Our cities are growing denser, and the demand for energy and water is skyrocketing. These issues loom large. They demand solutions. Scientists and environmentalists are working tirelessly to find ways to mitigate these problems. From developing renewable energy sources to advocating for sustainable practices, the fight to save our planet is ongoing. Protests and movements around the world are raising awareness and pushing for policy changes. Looking beyond Earth is no longer a luxury, but a necessity. As we explore the cosmos, we seek not just knowledge but also potential new homes. Space agencies and private companies are investing heavily in space exploration, launching missions to study other planets and celestial bodies. Mars, our red neighbor, emerges as a beacon of hope. Its proximity and similarities to Earth make it a prime candidate for colonization. The red planet has been the subject of fascination for centuries, and recent missions have revealed that it may have once harbored conditions suitable for life. This rusty world, once thought barren and lifeless, offers a potential escape route. The discovery of water ice and the possibility of liquid water beneath its surface have sparked excitement. Scientists are studying its soil, atmosphere, and geology to understand how we might live there. Could it be our next home? The idea of humans living on Mars is no longer just science fiction. Simulations and experiments on Earth are helping us prepare for the challenges of Martian life. From building habitats to growing food, we are taking the first steps toward making this dream a reality. The idea of terraforming Mars, transforming it into a habitable world, has captivated scientists and dreamers alike. But is it feasible? The process would involve altering the planet's atmosphere, temperature, and ecology to make it more Earth-like. This monumental task would require advanced technology and a deep understanding of Martian science. Can we truly turn this cold, arid planet into a second Earth within a mere century? The challenges are immense, from creating a breathable atmosphere to ensuring a stable climate. Yet the potential rewards are equally great. A successful terraforming effort could provide a new home for humanity and a fresh start for our species. The answer is complex, fraught with challenges yet brimming with exciting possibilities. As we stand on the brink of a new era in space exploration, the dream of making Mars our second home continues to inspire and drive us forward. The journey will be long and arduous, but the potential for a new beginning makes it a quest worth pursuing. Why Mars, you might ask? It's a question that has intrigued scientists, explorers, and dreamers for generations. Mars, the red planet, has always held a special place in our imaginations and our quest for knowledge. But why is it that Mars stands out among the celestial bodies in our solar system? Why not Venus, our other planetary neighbor? Venus, with its thick, toxic atmosphere and scorching surface temperatures, presents a hostile environment for human exploration and potential colonization. Its surface pressure is crushing and the planet is shrouded in clouds of sulfuric acid. The answer lies in Mars's unique characteristics. Mars offers a more hospitable environment compared to Venus. Its surface is rocky and varied, with mountains, valleys, and plains that tell a story of a dynamic geological past. The planet's topography is fascinating, with features like Olympus Mons, the tallest volcano in the solar system, and Valles Marineris, a canyon system that dwarfs the Grand Canyon. Mars bears striking similarities to Earth. It is often called Earth's sister planet because of these resemblances. Both planets have roughly the same land mass, and Mars's surface gravity is about 38% of Earth's, which is strong enough to support human activities and potentially even agriculture. Its day-night cycle is just over 24 hours long. This similarity to Earth's 24-hour day makes it easier for humans to adapt to life on Mars. The familiar rhythm of day and night would help maintain our circadian rhythms, which are crucial for our health and well-being. It has seasons, albeit more extreme than our own, due to its tilted axis. Mars experiences spring, summer, autumn, and winter, just like Earth. These seasonal changes affect the planet's weather and climate, creating a dynamic environment that could be harnessed for future human activities. Most importantly, Mars harbors water ice in its polar caps and beneath its surface. This water ice is a precious resource that could be used for drinking water, growing food, and even producing fuel for rockets. The presence of water ice makes Mars a prime candidate for sustaining human life. Water, the elixir of life, is crucial for any future human settlement. The discovery of water on Mars has fueled our dreams of establishing a human presence on the red planet. It opens up possibilities for creating a self-sustaining colony where humans can live, work, and thrive. These factors, coupled with its relatively close proximity to Earth, make Mars the ideal candidate for terraforming. The journey to Mars is challenging but feasible, and its potential for human habitation makes it a tantalizing target for future exploration and settlement. Mars beckons us with the promise of discovery and the hope of a new frontier. However, transforming Mars into a habitable world is no easy feat. The challenges are immense. Mars, often called the Red Planet, presents a myriad of environmental hurdles that make colonization a daunting task. From its thin atmosphere to its extreme temperatures, every aspect of Mars's environment poses a unique challenge. Mars possesses a thin atmosphere, about 1% the density of Earth's. This thin atmosphere is primarily composed of carbon dioxide, with trace amounts of other gases like nitrogen and argon. The lack of a substantial atmosphere means that the planet cannot retain heat, leading to drastic temperature fluctuations between day and night. This thin atmosphere offers little protection from harmful solar radiation. On Earth, our thick atmosphere and magnetic field shield us from the sun's deadly rays. But on Mars, the surface is bombarded with high levels of radiation, which can be detrimental to both human health and electronic equipment. It also results in extremely low surface pressure. The atmospheric pressure on Mars is less than 1% of that on Earth. This low pressure means that any liquid water on the surface would quickly evaporate or freeze, making it nearly impossible for stable bodies of water to exist. Liquid water cannot exist on the surface under these conditions. While there is evidence that Mars once had flowing rivers and lakes, today any water is likely to be found in the form of ice, either underground or at the polar caps. The search for liquid water is crucial because it is essential for life as we know it. The average Martian temperature hovers around a frigid -63°C. Temperatures can plummet even further during the night or in the winter, making the environment extremely harsh. These cold temperatures pose a significant challenge for any potential habitats or machinery, which would need to be specially designed to withstand such conditions. This makes it inhospitable to life as we know it. The combination of low temperatures, high radiation, and lack of liquid water creates an environment where life, at least as we understand it, would struggle to survive. Any future missions to Mars will need to address these challenges to create a sustainable living environment. Furthermore, Mars lacks a global magnetic field, leaving its surface exposed to the full brunt of solar wind. This absence of a magnetic field means that the planet's atmosphere is continuously being stripped away by solar winds, further complicating efforts to create a stable environment for human habitation. This radiation poses a significant threat to any future human colonists. To protect astronauts, habitats would need to be built with significant radiation shielding, possibly underground or using materials that can block or absorb radiation. Overcoming these environmental hurdles is essential for the dream of making Mars a second home for humanity. Despite these challenges, scientists have proposed several ambitious terraforming methods. These methods, if successful, could transform Mars into a more hospitable world. One proposed method involves thickening the Martian atmosphere. This could be achieved by releasing greenhouse gases trapped in the Martian soil and polar ice caps. These gases would trap heat from the sun, raising the planet's temperature and surface pressure. This in turn could allow for liquid water to exist on the surface. Melting the polar ice caps is another proposed strategy. This could be achieved by strategically placing large mirrors in orbit to reflect sunlight onto the poles. Melting the ice caps would release vast amounts of water and carbon dioxide, further thickening the atmosphere and warming the planet. Once the atmosphere becomes thicker and temperatures rise, we could introduce extremophile microorganisms. These hardy organisms could begin to convert Martian soil and atmosphere into more Earth-like conditions. This process, known as bioengineering, could pave the way for more complex life forms. Addressing the lack of a global magnetic field is crucial for long-term habitability. Scientists have proposed creating an artificial magnetosphere by placing a large magnetic dipole at the planet's Lagrange point. This would deflect harmful solar wind, protecting future Martian colonists and the developing biosphere. 100 years to transformation. A realistic timeline? While these proposed methods offer a glimmer of hope, the question remains, can we terraform Mars within a century? The answer, sadly, is likely no. Terraforming a planet is a monumental undertaking. It requires advanced technology, immense resources, and a unified global effort. While we have made significant technological advancements, achieving the level of sophistication required for terraforming Mars within 100 years seems unlikely. The timescale for such a project is more realistically measured in centuries, if not millennia. To terraform or not, ethical considerations. Beyond the technological hurdles, ethical considerations loom large. Do we have the right to terraform another planet, potentially altering its environment irrevocably? What if Martian life, however microbial, exists beneath the surface? Should we risk disturbing it for the sake of our own survival? These are complex questions with no easy answers. Open dialogue and careful consideration are paramount before embarking on such an ambitious endeavor. Mars or bust, a universe of challenges. Even if we surmount the technological and ethical challenges, terraforming Mars presents a myriad of practical concerns. Transporting the necessary equipment and resources to Mars is a logistical nightmare. The journey itself is fraught with risks, from radiation exposure to the psychological toll of prolonged space travel. Creating a self-sustaining colony on a terraformed Mars presents another set of challenges. Food production, waste management, and resource allocation require innovative solutions.